Okay, so we're on our last bit of imaginary numbers on section 1.3. So the first thing we have to do on this one, which I kind of already started, so pretend that's not there, is we're going to multiply this by the conjugate of the denominator, because you know how you can't leave a square root on the bottom of a fraction? Well, you definitely can't leave an imaginary number there. We need to get it to the form a plus bi. So we're going to multiply all of this by negative I. So 8 times, or I'll rewrite it real quick, negative I times 8 plus I, all over I times negative I. So now then we get negative 8I plus I times negative I over I times negative I. But this is going to be a negative I squared, which I should have wrote there as well. We'll keep going though. So I have a negative 8I subtract I squared over, I'll just do it again so it's less confusing. So I squared equals negative 1. So I have negative 8I subtract negative 1 over negative 1. I said negative a lot. Okay, so negative 8I plus 1 over a negative 1 is 1. Now then we have to rearrange this, so it would be 1 subtract 8I. And that would be your answer. This next part, it's just I don't even know the best way to explain it. So we know I to the first is I, or the square root of negative 1. I squared equals a negative 1. I cubed is a negative I. And I to the 4th power is positive 1. I'll go ahead and make so they don't all look so. And this pattern just repeats. So I to the 5th would be I to the 6th, 7th, 8th, 9th, 10th, 11th, 12th, so on and so forth, on and on, over and over again. So the way we figure out these, I'm going to one on my paper. Yeah, pretty much. So how they explain it, they have 1 over I to the 44th, and this is just negative exponent rules. So if I had tangent here, if I had 4 to the negative 2, or it'd end up being 1 over 4 squared, which is 1 over 16, and that's just negative exponent rules, so they used it on this one. And then if we had our 44, 44 is divisible by 4, so it's going to end up being 1, so we'd end up having 1 over 1, which equals 1. Let's say we had a different one. Let's say we had I to the 20th. So we'd have 20 is divisible by 4 over 2, so it would be a positive 1. This isn't the best way to answer this. 1 to the 18th, though, would be a negative 1. I to the 15th would be a negative I. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and I went right over 15, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So how I go about this, though, is I look and I see what's the biggest number that goes into my exponent. So 3 goes into 18, but that'd still be 6 left over, and 2 goes into 6. That doesn't seem to make the most sense, but that's how you do it. You can write them out and count, though, too. That's very confusing. Okay, I'm sorry if that didn't help any. Okay. On the 28th one, I'd say 4 goes into 28 7 times. So I'd have 1 plus negative 1 to the 4th, so it'd be subtract 1, subtract negative 1. So 1 plus a negative 1 is 0, subtract 1, you can't subtract a negative, plus 1, so subtract 0 equals, or 1 plus negative 1, subtract 1 plus 1. 1 subtract 1 is 0, subtract 1 plus 1, so negative 1 plus 1 is 0. Do I have another one after this? I need to think of a better way to explain this. But I to the 28th, using this here, let me make sure you can even see what I'm doing. Oh, you really can't too much. Darn. But I to the 28th, it's going to be a factor of 4. So that's why it's 1. I to the 22nd, it's an even number, it's not divisible by 4, it's going to be 2. Then I to the 4th obviously is 1, and I to the 2nd is negative 1, and they gave me the plus and the minuses here. So I substituted what needed to, so I had positive I, negative, positive 1, negative 1, positive 1, negative 1, and the subtract negative here turned to the plus sign. 1 plus negative 1 is 0, subtract 1 is negative 1, plus 1 is 0. That's the end on 1.3. If there's something you have questions on that I can explain better, please shoot me an email. I'll try and do it. I hope it helps.